Alrighty, so let's get started with the demystifying these programming languages. So this course or this particular video is not going to be so much as creating our code. There are many ways to create code, and I'll explain some of those differences all based on different developers. Though there is a common standard now in the professional world. First, we're going to be using JavaScript, which I'm not going to go into the full reason why it's in the HTML file, other than the fact that JavaScript runs inside of pages, and pages are HTML. Now, they don't have to be, because you can also make your own JavaScript file. But for this purpose, I'm making it as simple as possible just to have the code visible and running for show and for comparison between the two or three. And of course, we're going to have a little bit of Python just to get experience looking at different languages. What I've found that when you're looking at multiple languages, especially in the beginning, you're able to kind of grab a concept that's a little bit struggling when you're trying to learn it in a school environment. Because when you're in a school environment, you're essentially focused on one thing, and it's almost a zealous way for you to learn the language through the class and the tests and all the stuff they push through to you. However, you don't think twice about what you're doing and how you're doing it. And for the matter of fact, you don't even compare it to anything else to really start to see how the concept of programming actually works. Not the language specifically, because all languages have a little bit of a different grammar if we're thinking of it as a spoken language. They have different grammars, but still in the end, in a spoken language, you can be Spanish, English, Chinese. You're still creating a sentence. You're still creating a communication factor. Just different languages, right? Different grammar and structure. But the wording and the concept of what you're trying to say is the same. This is exactly how these particular three languages, and many, if not all of them, work in harmony with the concept. And that's what we're focusing here, is the concept, not the language. But this will give you a better perspective on how they compare, and maybe even give you a little motivation to seek the one that's more appealing to you. So let's start off with our old friend C++. So this would be one of the very low level languages, described as a hardware level language, because in the end, we are just writing human readable words, or as close to human readable as possible. And sometimes we don't even have to write words to describe what we are creating. We can just write random characters. In fact, all of these that you see, some decimal, some integer, a letter, a sentence, these aren't any programming specific words. These are my choice of variables to be specific about what they hold. And you'll see that happening in the other languages as well. So you have full control over how you name your particular variables. Now, what is a variable? Let's start with that, right? A variable you can consider as a box. That's it, a box. And what does a box do? It holds stuff, right? So depending on the size of the box, which is very important in C++, it can carry a certain amount of stuff, or in our cases, numbers, strings, characters, integers, etc., floats. We got to be very specific when we're in C++ and we're talking about numbers, because they come in many flavors, simply because the length and the details, signs, plus, minus, all of those affect the size of the variable itself in memory. So this is how we consider this a hardware level language. We are creating a variable, and it is being stored directly on your RAM card or on your cache for your processor, depending on, the running process. But most of the case scenario is it's going to be in RAM. And RAM has a specific layout and index of a bunch of numbers where it stores different parts or pieces of information like this variable. So as we're approaching this condition, this idea that a variable is directly represented inside of RAM, we have to be very diligent about what numbers, what values, what variable types we are using, and even how many decimals I put at the end of this, because if I put too many, it will end up essentially causing issues. There's only a certain size available, and you can also find those out if you search online for C++ variable sizes. That's when you're dealing with C++. This is one of the most hated things about C++, and honestly, I agree. But this is also the power of C++. It really is based on an intention of what you want your program to achieve. Sometimes you can do it directly on a simpler language like JavaScript or Python. Or sometimes you need to actually access the hardware layer to actually achieve something like a driver for a graphics card or a webcam or an operating system. Being able to also use the C++ language directly with the hardware does actually speed up the program that you create. The program runs much faster in this situation versus Chrome as HTML and JavaScript run, and versus Python. All of those are running on top of other software, while C++ is running on top of hardware, direct access to that hardware. And that's an important concept to remember, and also an important concept to attach to why all of this is so complicated. This shouldn't be a reason to really be demotivated because so many languages exist and you can achieve a lot of different things or goals or programs or whatever your ideas are in a much simpler language. But because this is kind of the introduction many students go through in college level, high school level, in university level, this is kind of what we learn, and we basically learn how to make a POS and how to add numbers and blah 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 blah, but that's not really the fun part. The fun part is when you start creating something more feasible. So let's continue. Well, what is all this stuff that I highlighted? In fact, let's be a little more direct. We have all of this code. Notice the alignment with the tabs. There is a tab for each line, about a single tab for each. Now, you don't necessarily have to do this in C++, but note for the future, you will have to do this in Python. You don't have to do this in C++ because it actually tells, or it knows where our code block begins with this curly brace here and where it ends with the other curly brace here. So we can kind of organize it visually just to make it nicer for us, and we can make these tabs here. No, these are tabs. Tab, 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 tab. I'm not going to redo it. So all of these are tabs. This one's a tab, that's a tab, that's a tab, all of these. But the case is, you don't actually have to. It's not going to break your program if you don't. It's just going to make it very messy. And if you share your program with somebody, they'll probably cry and never look at your code again. Now, further,